Welcome everyone. In this video, I will be taking a look at artificial intelligence or AI. My previous experience with AI, well, it's a little bit dated now. Early 1980s, to be a bit more specific, there wasn't much AI back then. There were a lot of theories, some programming examples, some articles, some database examples, and I tried several of them on my trusty Commodore 128. So yeah, I'm dating myself. However, AI has changed dramatically since then. Back in the day, I only had to deal with a few dozen or so parameters. Today, AI models of billions of parameters, a very significant upscale. What I want to do is run an AI model in a virtual machine. I'll be using Ollama as the application, as the application program interface or API for a few different large language models or LLMs. The goal of this exercise is to assess the performance characteristics of the various LLMs running locally. I want to pay particular attention to CPU and memory utilization. I mean, that's going to determine how big a LLM I can run on my laptop. I'm documenting my process and observations as I explore these possibilities. This is basically a record of that endeavor, and it is not a comprehensive tutorial, so don't treat it as such. So before we get too far along, a few things that need to be clarified. I've already set up virtualization on my laptop, so for the sake of brevity, I think this video is going to be a little longer than my normal. That's not going to be covered here. Though my laptop does have a discrete graphics card, I will not be doing any pass-through of the GPU, at least not this go around. I'll be using regular CPU cores, regular memory. This is not really the best option for artificial intelligence models or an LLM, but in my particular case, in this situation, it's the most practical for me right now. Like I say, I'm just doing this on my laptop, so we're going to see how this goes. Yeah. This video is going to be divided into a few parts. I want to first look at AI in general, where it's gone to since I last played around with it. Then I want to look at Ollama and LLMs specifically. While Ollama is not overly resource intensive, some LLMs, especially the larger ones, can be quite resource intensive. There needs to be some discussion about allocating sufficient resources to the VM to actually run the LLM models. I've chosen to use Debian 13 as my operating system of choice in the VM or virtual machine. That's Debian Trixie. It's not officially released yet, though it has been frozen and it has its own repositories now. So if things follow their normal pattern, it'll probably be released sometime this fall. I'm recording this in July, so yeah, sometime this fall they'll probably release the actual official release. And anyways, no problem getting a little experience with Debian 13 before it's launched. Can't hurt. The basic process will be to create the virtual machine, install the operating system, install Ollama, then install a few different LLMs and test their responsiveness and their resource requirements. So I guess I better get to it. Okay, I'm going to throw up here a basic AI model. You've probably seen variations of this various places on the web. It's concentric containers within the overall artificial intelligence set. While not the only visualization, the representation out there, it will do for my purposes here. Within the field of AI, machine learning is a branch dealing with enabling computers to learn from and expand on existing data sets without a specific direction to do so, aka human intervention. Within machine learning is a subset of generative AI or Gen AI, focused on creating new content from existing models in a variety of forms: media, sound, graphics, text, etc., etc. A subset within the generative AI is the large language model, which we'll be dealing with. Primarily a text input and output, answering queries based on one of the existing large language models that we have installed. My model for using Ollama starts with the user, myself, who passes information through an interface to the AI model. In this case, it's going to be actually a couple of stages. I've got one block here, but it's going to be PuTTY SSH'd into my virtual machine. So basically a terminal and text. The terminal then passes the user query to the AI itself, specifically the application program interface, aka Ollama. And Ollama works with the large language model, which is the actual brains of the artificial intelligence. The query is analyzed by the AI model and a response is generated. The response is sent back through the interface, the terminal, back to the user, me. And that's basically, we repeat over and over. As long as you're running a continuous session of Ollama, it actually remembers previous terminal entries and will use those as well. So that's basically what we're going to be doing. So let's talk a little bit about large language models. We need to specifically discuss the parameters and the resource requirements those parameters generate. When we look up an LLM on the Ollama website, there are a few parameters to consider. First one, when you look up LLM, is going to be ARCH, which is short for architecture. This goes back to who built the model and who trained the model and for what purpose. For example, QWEN models come from China, Gemma models come from Google, and Llama comes from Meta, your Facebook parent company. Yes, they are run locally, but require resources to set up and train, and that's where the big tech companies come in. Parameters deal with the number of settings, rules, instructions within the LLM itself, and these are measured in the billions. And this is what sort of sifts through the data, how the data is sifted through. There's something else called quantization. It's a method of compressing the data so it takes less physical memory. The downside is a loss in precision with some of your outputs. However, depending on the type of query you're running, this really only becomes apparent when you're doing complex or specific queries. The actual downside or the actual download size is also given in gigabytes, so you can estimate how long it'll take to download these models. Let's talk memory usage. I do need to point out that the actual RAM usage is somewhat different than the storage space. Let's look at a simple way to derive a general idea of how much RAM a particular model is going to require. This is not by no means super accurate, but it'll give you a general ballpark figure. So we already covered the quantization and the parameters. The parameters will be used with the billion suffix. Quantization, you'll get a constant based on the level of quantization, whether it's float 32, which is basically the model as it is, float 16, integer 8, or integer 4. There's also an overhead cost to doing a business, and depending on how we're using the LLM is going to depend on the overhead cost. We're going to be using the text, not reasoning or any of the graphics or sound. So we're going to multiply all three of these together to get an estimate of the RAM to run the model. So again, that's a quick and dirty way. We're actually a little bit later going to look at a website which will calculate this for you, but this is just a quick and dirty way to estimate whether you can run a model or not. All right, let's take a look at the setup. So as I said before, I'm using my laptop. I have virtualization turned on in my laptop's firmware, and I have it loaded on board. Depending on the processor, it'll be well, for you, depending on the processor, it'll either be Intel VTX or AMD 5 in your firmware that you need to turn on for virtualization. Mine's got an Intel processor, so I use Intel VT-X, and again, this is in your firmware. Since I'm using Linux, I have the kernel-based virtualization machine, or KVM, installed as a Linux kernel module. Basically, it's usually installed by default now on most Linux systems. I'll be using a QEMU program, or QEMU. It's a hardware emulator for your virtual machine, which will emulate the various types of hardware out there, depending on your machine's requirements. Virt Manager is installed to give me a GUI. This also pulls in libvirt, which is the actual command line interface through Virsh, VIRSH. But we're going to be using libvirt because it's a visual GUI manager, and it's simpler. I mean, Verse is not hard once you get used to it, but yeah. These pieces work together to create, maintain our virtual machine. The virtual machine itself will use Debian 13 as the operating system, or OS. Ollama will be installed via the script from the website, and then we'll use Ollama to pull down the LLM and install it, and then run it. So that's basically my setup here, what we're going to be doing. So yeah. Now, as I said earlier, there are a few websites that actually have some the purpose of helping you figure out how much RAM your LLM is going to take. We're looking at one of them here. We set the quantization level. Incidentally, I've noticed a lot of the models that you download for Ollama are Q4 or 4-bit integers, so that's one of the smaller ones. And once you set that up, you can move the RAM slider, and it'll tell you the number of parameters in billions that you can use with that much RAM. So, like I said, there's a couple other sites out there that do this, but it's just a quick and dirty way if you want to alternate way instead of doing the math yourself of determining how much RAM you're going to need. And again, you look at the information from the model page of the Ollama website to figure this stuff out. Next up, we want to get the Debian Trixie net install CD ISO, so we'll just do a search for that. At least as of this recording, this will take you to the Debian 12 web page. We want to look for images for testing release and click on the link there, and that'll take us to where we can find the Trixie ISO. The net install ISO is 769 megabytes. And as I said, Debian 13 has its own repository now, separate from testing, and you'll see that when we get into it. Note that I am only going to do a very basic install, no GUI tools. Debian 13 will be in, which is in full freeze in the middle of May, is when that happened, and it is. And if it, like I say, if it follows progression, it should see a full release sometime in the fall of 2025. Before moving away from this topic, I want to talk about Virt Manager pools. Virt Manager has pools or volumes used, and this is where it stores its various types of data, like ISO files and actual virtual machine files. The default is outside of my home directory, which limits access depending on permissions. You may have to use sudo in some cases. Regardless, I prefer to keep everything within my home directory, so I'm going to have created my own pools, and we'll take a look at those when we use Virt Manager. I assigned a folder as a pool for my ISO files. I also assigned a hidden folder as a storage pool for my VMs, both of which reside in my home directory. Okay, once Debian Trixie is downloaded and placed in the ISO folder, I can start Virt Manager and to add a new VM. I select the left-hand monitor icon with a star on it. Since I'm installing from an ISO, I select that as the first option. Since I just moved the ISO from download folder, it will not necessarily show up in the drop-down selector, so I have to browse for it. Here when we click on the browse button, we can see the various pools, and you can see the two default ones and the one I created. I want to select the ISO pool, then Trixie from there. Now, interestingly, because the name of the file is not standardized yet, I do not get an auto detect on the operating system type. Now, if I switch over and flip and choose a Debian 12 ISO, that will automatically come up with Debian 12 as the operating system type. But using Debian 13, I'll need to enter that manually and uncheck the auto and enter it manually. Next comes the RAM and CPU assignments. 2 gigabytes of RAM and 2 CPU cores set by the OS type. We can change this, but I'm going to leave it like it is for now. I suspect I will need to come back and increase the RAM and CPU cores with the larger LLM or large language models. Now I create a virtual storage drive. The default will be stored outside of my home folder, so I choose do custom storage option and create a 200 gigabyte drive for the VM. After the drive is selected, comes the create virtual machine window. You want to make sure to check customization of configuration before install. This will open the new VM's configuration screen instead of just going directly to install. So here on the configuration screen, I will add a title and some descriptive information so I know what this VM is when I look at it and I can track it better. Also, at this point, I can select UEFI boot or standard BIOS boot. I'm going to go UEFI here. Well, here I review the various options available before continuing. None of these are really going to change at this point. Once ready, I click Begin Installation in the upper left corner. I normally use a text installer rather than the GUI installer. I'm going to cover the Debian install fairly quickly here, just making notes where non-default inputs are required. Things like country and language people can figure out for themselves. Be careful of the host name formatting. You will get a red screen if it is wrong. It can only be standard ASCII 2 characters, nothing wild, no underscores or things like that. If you are not on the internet, you probably don't need a domain name. Of course, if you're not on the internet, you're probably not installing from this ISO anyways, but I usually add one just in case. Home.arpa is recommended and reserved for residential networks. If you don't have one, you want to add one, you can use this. It's cheap enough to buy a domain name, and I have one that I'm going to use here, which is basically one I always use for testing. If you leave the root password blank, the installer will set up sudo for you automatically with the normal account administrative jobs. You will need to create a normal user account regardless, but if you do enter a password for root, the root account will be active and sudo will not be initially installed. When partitioning comes up, let's keep it simple. We're going to go guided partitioning with everything in one partition. Once we get to the package manager setup, since I have no proxy, I'll leave that blank. I can say choose appropriate region and appropriate server. I just go with the defaults. I say no to the Debian software popularity contest. That's their only bit of tracking or telemetry, if you want to call it that, but it's set to off by default, or no by default. I uncheck the Debian desktop and GNOME, and then check SSH server. I leave the common utilities check. Debian in this case will automatically. We will then head over to the actual install itself will start, and Debian in this case will automatically find the boot drive and set up the bootloader. And that's it. I'm done with the installed Debian. It's now ready to use with a simple console interface. Because I created a root account, sudo was not installed. I need to log in as root, install it, and grant my normal user access. There are a lot of opinions on the whole root account security thing. I'm not going to get into that here. I'm not going to discuss the pros and cons. I'm just doing things the way I like to do it. So you may have your own way of doing it. So after logging in as root, I use apt to install sudo. Then check the vi sudo file to make sure that sudo group has been activated. Then next I add my user to the sudo group with the usermod -a large G sudo RT. Or sudo is the command or the group and RT is my user. One thing I do need to finish up with the console is get my IP address. So I use IP _A to find my IP address. It's not static. If this was going to be a long-term server, I would have set up a static IP address during the install, but since this is just short-term for a test, I didn't bother. Okay, moving on along. We reboot the server. We're up and running. We've got sudo installed and set up correctly for my user. Time to log in with our remote SSH terminal. In this case, PuTTY. I'm using PuTTY as my client. And yes, I know it can be done from the command line and from any terminal. Well, but to make this as general as possible, I'm sticking to GUIs as much as possible. I set the IP address in PuTTY and log in. As this is the first time I will get a security alert, at which I click accept and continue. I then find myself at the login screen, probably easier to see in the video. SSH is set up by default to not allow root login, so I need to log in as a normal user, which is why I need to give myself sudo privileges first. I did go and peek at over at the Ollama page and noted they use curl instead of wget, which is installed by default to run their script, but that's fine. I'll go ahead and install curl since I will need that. Again, sudo apt install curl. And once that's done, I can go ahead and head over to the Ollama installation page. From the Ollama install page for Linux, I'm going to go ahead and copy the shell command. However, when I paste it in, I'm going to modify it slightly. Instead of running it and piping it into SH, I'm going to pipe it into a program called less, which is a text reader. I want to take a few moments to actually look at what's written in this script before I run it on my computer. I suggest everybody do that. For myself, I want to know what is in the script and what it's going to be doing, especially if I get it from the internet before I run it. If you want to learn Bash, reading a few of these scripts is a good way to, and figuring them out is a good way to get a heads up on it. Looking at this, a lot of the script is just determining what type of OS or Linux distribution is being used, and then tailoring the Ollama installation for that distribution. I don't really see anything overtly evil here. So the next step is to run the script as written, piping it to the shell sh for execution. The script uses the user local, so I ran it with sudo. Not sure if I needed to. Something to test out on the next install. A quick note. No GUI detected. As I said, I didn't do a pass-through on my graphics card, so yeah, no GUI. We'll be running an Ollama on a regular old CPU cores and regular old RAM. Next, I want to check if Ollama is actually installed and running in the background. So I'm going to use system control, status, Ollama. I use sudo with this. You don't have to. The only difference is if you don't use sudo, you're not going to see any of the related journal entries. It'll say you don't have enough privileges. If you use sudo, you'll see them. That's really the only difference between using sudo and not using sudo. I can also run Ollama list to show if it is indeed running, and you'll note we have no LLMs installed. As we did earlier, we'll go ahead and get the names of the various LLMs from the Ollama website model page, then use Ollama to pull them down and install them. I will try one of the smaller models first, DeepSeek RA colon 1.5B. So I use Ollama pull to grab it. If I do an Ollama list after it's finished downloading, I can see that it's been installed. So the next thing I do an Ollama run DeepSeek TAC RA colon 1.5B, and the model should run. I'm actually somewhat surprised since I only have 2 gigabytes of RAM set up. Actually, I think I remember from the partition page where it was writing them that it did create a swap partition which would add to my RAM, so I shouldn't be too surprised. Anyway, I go ahead and do my default question I'm going to use. So I ask it, why is the sky blue? And examine the results. Surprisingly, this one actually runs fairly quickly. I was expecting it to be somewhat slower since I'm using regular CPU and regular memory. And it's a fairly long answer. So that's one thing I noticed is these tend to give long answers. One thing I want to note, however, once the answer is done, you can exit the model by typing /BYE at the Ollama entry line, and that should take you back to the command line. So next, let's up the game a little and go with the same DeepSeek R1, but we'll use the 7B, which is a slightly larger model. That's 1.5 billion parameters versus 7 billion parameters. Downloads without a problem. However, when I try to run it, it complains about memory. I need to add more. So I basically need to shut everything down, go into that info page and up the RAM. So I'm going to go ahead and give this one 8 gigabytes of RAM. Now when we rerun the VM and Ollama, it can launch this LLM model. However, I noticed Ollama is now running somewhat slower. It's not unusable, it's just slower. The answer to the sky blue question also seems to be a little longer. One thing I want to try real quick here is I'm going to stop the CPU, I'm going to stop my VM again, and I'm going to go back to that info page, and I'm going to up the number of CPUs to 4 and see if that helps. Which it does actually improve the speed at which Ollama is running at. So yeah, more CPUs do help. All right, let's try a bigger model. We'll go with a DeepSeek RA8B, which 8 billion parameters. That's slightly larger. We'll load it up, run it, and a longer explanation now also includes something about railing scattering that wasn't in the earlier models. Again, larger model, more parameters, more information. So I should expect to be slightly different in the answers. All right, time to up the ante again. This time we're going to load a different model, not the DeepSeek. We're going to choose the Gemma 3, and I'm going to go with the 12B or 12 billion parameter model. And of course, this also fails to run, so back to the info page and up in the memory to 16 gigabytes. After that, the model does run, and there is definitely a shift in the way this model answers questions. The formatting is somewhat different. It's running a little bit slow, so I'll go ahead and up the CPU count again for this model and see how that helps. Boosting the CPU count, yeah, it does speed up the model. Doesn't appear to be as much a speed boost on this one as it was on the previous. Feels like I may be reaching some sort of limit here. Who knows? So far, things are going pretty good, and I'm getting some pretty decent information from these various models. I have a pretty good idea how things are going to work. Based on what I have observed so far, I don't think I could run anything bigger than, say, a 30B model on my laptop. I'd probably need at least not at reasonable speeds. I'd probably need a dedicated computer, and I'm told that GPUs will run this faster. There are actually AI chips out there now that'll run faster too. I may think I could probably squeeze a 70B model, maybe, but it would be dead slow on my current setup. I'm not going to try it yet. In fact, I'm probably not going to try at all, because like I say, if it did run, it'd be dead slow. And I think with that 70B model, I'd probably have to add some additional swap space. So yeah, I'm guessing for normal running, 30B is probably about the biggest model I can install. All right, that's about it for this video. So far, it's been a pretty interesting dive into AI. Very limited AI that it is, it's still AI. There's a lot more AI things I haven't looked at or covered. Like I said, it's my first dive back into it after a long time, and I was never really into it at this level before. Just played around with it a little back in the 80s. But as I said, there's a lot of AI-related things I really haven't covered, I really haven't looked into yet. One of them you might be asking, I've talked about training models. Can you train your own models? Again, something I need to look in, but I think that's going to take a lot of computer resources, a lot of time. That's why you've got people like Google and Meta building these models, because they've got the resources and they've got the time and they've got the people. But that's something to look into, how long it would take to actually train your own model. There are also other projects out there that can actually improve the overall usefulness and accuracy of your AI model, even if it's a limited AI model. One of them is Retrieval Augmented Generation, or RAG. This one is where you can take some of your own documents and feed them into your query to your AI through the RAG application. and they will be considered and they will be used to help parse an answer to a, like say for a specific computer, a specific piece of hardware or something like that. I mean, you can do it if you get the right documentation. You can get much more accurate, more specific answers out of your artificial intelligence. So maybe in another video, I'll take a look at something like RAG and see how that would work. Also, the interface. One example you could use a web UI is a project. Open Web UI is a project that has caught my interest, giving Ollama a web-based interface. But for now, I'm satisfied that I can run LLM AI in a VM on my laptop. I can actually run it fairly quickly as long as I don't try to go with too big of an LLM. There are some size restrictions there. I can see why people build a dedicated, customized PC to run an AI. So local AI is really not out of reach for the home user, and I guess that is my biggest takeaway. As always, if you enjoyed this video, please like, share, comment, subscribe, all that fun stuff, and we'll see you next time.